Alright, for this example, we're going to start just another 2-inch cylinder. So we'll go back into planes and just put the C and T on the left-hand side. I'm going to go isometric and just twist it around so it looks like that. Make sure I'm in 2D, and I'm going to go to wireframe, select a circle, and make it a 2-inch diameter. And I will then go to solids and extrude it. And let's say the length is going to be 2 inches. Okay, something like that. Alright, so now I'll get in my levels, and I'm just going to name this as stock. I'm going to do a new level, and this is going to be Helix info. Alright, so there's our stock. So now what I want to do is I'm going to get back into planes. I'm going to go back to top view. I'm going to go into levels, and I'm going to turn the stock off. Go to top view. So now we're ready to cut a helix. So like the engraving that I showed you before, what we're going to do is we're going to use a flat 2D geometry and roll it using the axis substitution. So what we need to do is draw a quick triangle. Okay, the first line is going to be the vertical line here of this triangle, and there's a little bit of math here. You're going to have the number of spirals you want times pi times the diameter of the shaft. I am going to double check the diameter of the shaft. It should be 2 inches, but you always want to double check this. Okay, and let's go into home, analyze entity, and it should be a 2-inch diameter. Good. So I'll turn the stock back off and go to top view. So what I'll do now is I'll turn up, get a line endpoint. Okay, and I'll just draw a line. So what I'm going to do is I'm going to end up doing, let's do 3 spirals. Okay, it's going to be 3 times 3.1415, it'd be good enough, times, okay, 2 inches. And we get 18.849. Type in 18.849. Okay, you could also do the equation in here, but I prefer not to do that. So we'll hit green check, and there's our line. Okay, now this opposite side here is going to be the length of the cylinder that we want this helix to be on. So what I want to double check again is go to stock and look at it, and I'm just going to do a quick home, analyze distance, and we'll go here to here, and it's 2 inches. Okay, so we'll go back into here, and we'll do a new line, 2 inches. Okay. Then what I'm going to do is create the hypotenuse just by clicking the endpoints. So there is our geometry for our helix. Okay. So I'll pause here, and we'll continue. Alright, so now we're back. We have the geometry we need for this simple helix. We're going to go to Toolpaths, Machine, Mill, Generic Cost 4-Axis. Okay, we will again add another toolpath group, and the first toolpath group we'll call Stock. The second toolpath group will be Helix. Okay, let's bring our cursor up under Stock and do a stock model. Okay, green check, and I'll turn that off, and I'll also go into levels and turn stock off for now. Alright, go back into toolpaths under Helix. Right. I'm not worried about the other information up here as far as the sequential tools. I'm not worried about that for now. Bring our cursor down. We're going to go to contour. We are going to change just the hypotenuse, so be careful and don't do what I just did. Make sure you go to single entity, which should be right here, and just that portion. We're going to go to Tool, select Library Tool, and not an engraving tool this time. We're going to go to the filter and select a flat end mill that is equal to 0.1875, so 3/16. There it is. Name the node Helix. I'm not really worried about your speeds and feeds. For this is just showing you how to do a helix. I will change the tool to 1. Cut parameters. We're going to have no comp on this, so it is off. It's just be almost just following a straight helix. So just trying to keep it as simple as possible. Lead in, lead out, we can remain on, but we're going to have to adjust the start and end of the contour here. Now, I'm not really worried about the fact that the chuck is going to be here. I'm just showing you how to get a helix on a part. So, you know, you have to make sure that where this ends is not going to hit anything, or what is after there, a fixture, you name it. So we're going to adjust both of these. We're going to extend both of them. Okay, and let's just do a distance of like 1/4 of an inch. Okay, and now we can get into linking parameters, and I'll turn clearance on, start and end, turn them to incremental, and we're going to do a depth of minus 0.25. Okay. Now we can get into everything else is okay. Now we're getting into rotary axis control, axis substitution. Substitute the y-axis, clockwise. Rotor diameter is 2 inches. So now we'll hit green check, and you will see that we have a helix. All right, let's go ahead and simulate this. We'll get in our simulator settings, make sure the stock model stock is on for the simulator options, and let's verify this. So we'll hit play. And so we got 1 rotation, 2 rotation, 3 rotation. Now, we got 2 issues. One is there's a little bit of radius here. That's from the lead in. And the lead out gouges right into the workpiece. So let's go ahead and fix that. Alright, so let's fix this helix. So there's our one issue, there's our other issue. Now let's take a look at this, turn the stock on, and you'll see the little issues where they're at. Okay, so let's take a look at this in toolpaths, and this is a lead in, lead out issue. So there's our lead in, lead out. Okay, and what we want to do is, there's a couple ways to fix this. One way to fix this is on the entry, you can actually increase it to 1 inch. So let's increase that, hit green check, regenerate, and you'll see it's much longer. And if we verify this, you will not see that radius anymore. I'll zip right through this. You will not see the radius anymore in the beginning. So that did fix this one. I don't see any problems there. But we still have the issue to address on the backside. So to fix that, what we need to do is go to parameters. The sweep on the exit arc goes to -90. Green check, regenerate. It'll pivot the arc that way. All right. Now if we verify this and hit play, it's helixing in, cutting around on the A. All right. Now it is much better, but we still have that little bit of an issue here. So let's fix that. Okay, by increasing the length to 1 inch, like we did the other side. Hit 1 inch, green check, and there they are the same on each side. Now there are issues here again. If you have clearance issues here, you're going to have to tweak some of these settings to work with that. But just for this example, that's fine. We can verify again, and hopefully this part looks okay now. It comes in. And you'll see that we have our helix cut pretty clean. All right. So that's cutting a simple helix, 4-axis simultaneous in Mastercam. Let's take a look at the code for this. And you'll see the code. So it starts here, starts at A-65, it works its way negative, works its way around. Okay. Go back to A0 at the end. So there's our program. All right, looks good. And we can check this out in Backplot. Now, Backplot has a couple interesting settings. One thing I'll point you to is if you have the editor, this little exclamation mark, go make sure Simulate Rotary Axis is checked. And then when you play this, it'll spin. Instead of the tool going around the workpiece, it'll spin the actual workpiece. See how it spins everything? So there we are, cutting around. All right. Part is spinning. If you don't do that, the tool will move around. Some people like that, but I'd rather see a more realistic interpretation of it. So there it is. Okay. You could do depth of cuts here. That'll all work. So you do depth of cuts in 100, let's say 50 thou. If you regen that, you'll see the depth of cuts. There they are. Okay, and it rewinds back. That's fine for this. But anyway, there's cutting a simple helix using contour and just rotary axis substitution. And again, the key here is going to be not only creating the correct triangle and the right geometry to do so, but also the rotary axis control, axis substitution. We're substituting the y-axis around a rotary diameter of 2 inches. All right. So hope you learned something. Thanks.